Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year, and it accounts for 4% of the 9 inches of sea level rise that's happened so far. Some scientists are predicting that the whole thing might melt in decades rather than centuries. But we don't even have a few decades to hang around, let alone centuries. So I'm going to show you what happens if it melts a whole lot sooner, in seconds. In just a few seconds, Thwaites has melted and flowed into the Southern Ocean that surrounds it, and from there into the Indian Ocean, the Atlantic, and the Pacific. Sea levels rise by 60 centimeters around the world. The streets of San Francisco are getting flooded. Miami and New Orleans are also rushed with water. But what's going on? Why did this glacier crack and break away from the rest? Well, there's something going on underneath. Beneath Thwaites is a massive river flowing fast. Melted ice from the iceberg is feeding it. This is happening thanks to geothermal energy from the Earth's molten interior. The melting process starts off slow, but eventually huge chunks of ice break off. This starts a chain reaction, causing more and more ice to break off and melt. And there's more to it than just one river. A whole world of mysteries lies beneath the ice of Antarctica. But before I take you to that fascinating underworld, I want to tell you about why Antarctica is so important. It's an ice sheet covering an area of 14 million square kilometers, with an average thickness of over 2 kilometers. Just for comparison, that's 1.5 times the area of the United States. That is a staggering amount of ice, 25 million cubic kilometers of it. It's 90% of all the ice on the globe, and locked up in that ice is 60% of Earth's fresh water. Now, unlike the Arctic, where the ice is floating on water, there's land beneath the ice in Antarctica. You don't think about it because 98% of the land is covered with ice. And that's not all. 1.5 million square kilometers of ocean is also hiding underneath this ice. And when all this ice melts in a few minutes, sea levels are going to rise an astounding 70 meters. We'll see what this epic meltdown does to Earth in a bit. But first, I want to show you the bizarre creatures we're discovering inside this frozen landscape. As you explore this uncharted territory, you'll get a peek at the ocean floor, and just above you, you'll see the underside of the ice. Here, you'll find a type of marine life called anemones. These tiny little creatures are burrowed into the underside of the ice. You'll also find some other small fish and crustaceans. The anemones you find are going to be very different from what you'd find normally in the ocean. They're a new species with an unusual trait. See, anemones usually stay rooted to a single spot, kind of like a plant, but these Antarctic anemones wriggle about in the water. Scientists are still figuring out where they're trying to go. Okay, almost nothing grows in that cold darkness, right? So, what are these creatures eating, and how are they surviving? Well, it's probably little bits of plankton and poop ferried in by ocean currents, but they're also eating something that's super weird and kind of gross. It's the ocean equivalent of rotting food in the back of your fridge. These creatures are eating millions of year-old rotting skeletons, bodies, and ancient bacteria that were around when Earth was much warmer. Ooh, watch out! A few more massive glaciers are about to break off. As the neighboring glaciers to Thwaites separate and melt, more water pours into the oceans. Worldwide, sea levels rise another 2.5 meters. Cities on the east coast of the United States are covered in water. Boston, New York, Miami, millions of people are affected. Even as cities are getting submerged, something bizarre would be going on right off the coast of Antarctica. Close by, the sea level would actually be falling as all this ice was melting, while the sea level further away would be rising. Now, why would this strange event be happening? Well, remember, the Antarctic ice sheet is enormous. It weighs a mind-boggling 24 billion megatons. So it exerts its own gravitational pull on the surrounding waters, which raises the sea level nearby. But when the ice melts, the power of that gravity is gone, so sea levels nearby fall, just as they're getting higher elsewhere. Over in the east end of Antarctica, the Denmark and Scots glaciers have melted. This adds another 1.5 meters of water to our oceans. Now, at a 4-meter rise, the United States is now losing national monuments. The Jefferson Memorial is underwater, Fenway Park is submerged, major coastal cities around the world are also flooded. Shanghai, Lagos, Mumbai, Jakarta, ports are flooded and destroyed. And all that salty water is flowing into farmland and destroying our crops. Even worse, underground aquifers that give us drinking water are now contaminated with saline spilling over from the ocean. What's scarier is that the contamination runs deeper than just salt. The Antarctic ice carries bacteria that have traits that are dangerous to human beings. Some of these bacteria cause infections, and they're linked to diseases like cystic fibrosis. But it gets worse. They have an even more deadly superpower. They're resistant to the antibiotics we use to treat diseases today. If they exchange parts of their genes with the bacteria of our world, the resistance to drugs will only grow and spread to even more bacteria. At this point, we humans would be toast. We'd no longer be able to fight off bacterial infections. Not good if we're drinking contaminated water. But like any Hollywood villain, these bacteria also have a good side. They can help us create new and better antibiotics. They can help clean up toxic waste sites and maybe even be part of a new biodegradable alternative to plastics. As more and more ice breaks off and melts, other ecological systems are getting thrown out of whack. For one, the melting ice is changing the way ocean currents flow. Before all this ice melted, the water in the oceans moved around in a very particular way. Dense, salty water sank to the bottom of the ocean floor, pushing the less dense water up to the surface. Through this movement, the water acted like a giant conveyor belt, transporting heat and nutrients from one place to another. This is a key factor for the survival of marine life. Now, with fresh water from melting glaciers entering the picture, the water at the ocean's surface becomes less salty and dense and doesn't sink down as far. It's like our ocean conveyor belt has been jammed up. It's no longer able to move heat around from one place to another. Scientists warn that the melting of the Arctic will mess with the warm Gulf Stream. They're still figuring out how an Antarctic ice melt will change our climate. Under some circumstances, for instance, if icebergs broke from the Antarctic and melted further away in the Atlantic, the changes in ocean circulation could bring on an ice age. But if the melting primarily caused sea levels to rise, well, we'd probably just end up with a warmer Earth. And it's not just heat patterns that we need to worry about. Breaking the oceanic conveyor belt means problems with the movement of nutrients from the ocean floor to the surface. These nutrients are important for the growth of phytoplankton, tiny algae at the bottom of the ocean food chain. They may seem small and insignificant, but they're the bedrock of life in the ocean. They provide essential nutrients to marine life. But not all phytoplankton would suffer the same fate. For the phytoplankton around Antarctica's waters, the melting ice would provide iron and give them something rich to feast on. In fact, this event might lead to a temporary massive algae bloom as the waters are flooded with nutrients that were previously buried in the ice. The growth of the phytoplankton might be a good thing because at least they'll absorb a little carbon dioxide. The Earth will need that. Why? Well, because all this ice melting is going to make the planet a lot hotter for several reasons. First, ice helps keep Earth cooler through its super reflective surface. It's very effective at bouncing sunlight away from Earth's surface, which helps keep things cool. But once it's melted, that's a different story. With glaciers melting and the water warming, the activity of microscopic fungi in the water is also picking up. Just like dead leaves decompose in forests, microscopic fungi act on dead matter in the oceans, decomposing it and releasing carbon dioxide. Warmer oceans mean more dead matter gets decomposed, leading to more carbon dioxide being released. Now, on top of this, the melting glaciers create a layer of fresh water on top of the salty ocean water. This causes the oceans to be less efficient at removing carbon dioxide from the air, again, adding to the warming. And now, the rest of Antarctica is breaking up into humongous chunks and melting rapidly. Water from the melting ice pouring into the oceans. As the ice melts, something amazing is revealed. A natural wonder that's been hidden for millions of years. An enormous canyon system, 100 kilometers longer than the Grand Canyon. It's the deepest canyon on Earth, running 3.5 kilometers below sea level and stretching all the way from the interior to the coast. And now you can also see the 15-million-year-old Lake Vostok, the 6th largest lake in the world by volume. And good news, with all the ice melted, you can picnic there. If you're still in the mood to picnic after everything the Earth is going through. Plus, you might want to stay away from the microorganisms living in the waters of Lake Vostok. They've been evolving there, isolated from the influences of our world for 15 million years. Who knows what they could do to your body? But there's no time to admire the canyon or peer at Lake Vostok because sea levels are rising, higher and faster than before. You're witnessing the last and most dangerous stretch. Every last chunk of ice is melted. Sea levels have risen over 70 meters. This rapid rise has caught people by surprise. 40% of the world's population, over 3 billion people, live near a coastline, and the vast majority of them have drowned as Antarctica's ice has melted in a matter of minutes. The entire Atlantic seaboard, including huge chunks of the United States, is gone, submerged underwater. People in skyscrapers as high as 23 stories are forced to race to the rooftop in a desperate bid to survive. Parts of California are transformed into bunches of little islands surrounded by water, and other parts of the state are completely gone. London, Paris, Venice, and every major coastal city we know and love is underwater. Millions of people are displaced, injured, or potentially dying from this catastrophic event. Anyone smart enough to jump in their car and flee inland as the water first started pouring onto land may have escaped with their lives if they could get to higher ground, but those are only a lucky few. Governments are in a panic, deploying emergency operations. They know that almost everyone on the coast is drowned, but maybe there's a way to rescue desperate people on top of skyscrapers. But with so many people affected, are there enough helicopters to even rescue these people? boats would be needed. How will governments be able to replace all the destroyed infrastructure? More importantly, what will we do about the sudden lack of fresh water? With our fresh water mixed with salt water, humans now have a serious lack of drinking water. Suddenly, the land in the interior has become the hottest property. People living in the US Midwest are super happy they were never ever part of the wealthy coastal elite. Denver, Minneapolis, and Las Vegas are looking more attractive than ever before. Now, nations in the southern part of the globe are hit even harder. All of Bangladesh, with a population of 160 million people, is underwater. Geopolitical tensions rise as countries are looking for aid, but since so many places are hit, help is hard to come by. Now that all of the ice is gone, there's still another thing that has to melt: the permafrost. This is the soil that's been frozen at the poles for more than 40,000 years. As it thaws, it releases the carbon dioxide and methane that are trapped underneath it, causing the Earth to warm more and melt even more of the permafrost. As the permafrost thaws, it's as if someone popped a frozen dinner into the microwave. Tiny organisms start to munch on the freshly thawed ancient organic matter. As they do this, they fart out carbon dioxide and methane, which causes global temperatures to rise even more. Great, now we're breathing in microorganism farts and it's getting hotter. Worst scenario ever. Oh, but it can get even worse. In the midst of all this, it's possible that DNA viruses in the permafrost will thaw and kick off a global pandemic. Creating a vaccine in the midst of this catastrophe would be a challenge like never before. Plus, it's hot. Earth is 5 to 10 degrees Celsius warmer. The heat is what's driven the entire ice sheet to melt, but now these changes are making it even hotter. With the average temperature on Earth now almost 27 degrees Celsius, a mass migration of people begins. The most popular spots? Well, Canada, Alaska, and the newly unveiled Arctic and Antarctic regions. These are the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest like New Zealand. Maybe that's going to happen all over again. Palm trees on the Antarctic coast and alligators swimming in the warm South Ocean. Thank goodness Antarctica is not actually melting in a matter of minutes. With coastal cities turning into watery graves, 3 billion people dead, our groundwater contaminated, more warming on the way, and maybe a global pandemic, I can't think of a worse situation. Unless, of course, land and water suddenly switched places.
What if we found a way to drain all the Earth's oceans through some mysterious portal at the bottom of the Mariana Trench? How long would it take? Years? Centuries? Millennia? Would there be any life left on Earth when the pumping was over? What if it happened overnight? This is What If, and here's what would happen if we drained all the world's oceans. Ocean water makes up 70% of the Earth's surface. How much liquid is that exactly? Well, if you could put all that water into Olympic-sized swimming pools, you'd need this many of them. Even if we opened a portal about the size of a basketball court, it would take us hundreds of thousands of years to drain the oceans. They hold over 1 billion cubic kilometers of water. But what if we had a pump powerful enough to drain all the oceans in a minute? What would happen then? Sure enough, swimmers, sailors, cruise passengers, everyone out on the ocean would feel the effects quickly. Within a second, boaters and swimmers in shallow water would crash onto the bottom. They'd get away with a few broken bones. Deep ocean ships wouldn't be so lucky. A Titanic-sized liner would hit the bottom in 30 seconds and smash into tiny pieces. The same thing would happen to just about every large ship on the ocean within the first minute. What about all the sea creatures? You already know the answer. It would literally be raining fish, since all the whales, dolphins, and other big aquatic animals curiously exploring the surface would be falling to the ocean floor. As for those already near the bottom, they'd be lucky not to get sucked down the drain along with the water. But what comes next is where the real trouble begins. Our oceans have two life-supporting roles. First, they regulate global temperatures by absorbing energy from the sun. They push warm tropical waters north and south and circulate cold waters back to the equator. This way, no place on Earth gets too hot or way too cold. Global climate control. Second, oceans feed the water cycle, evaporating into the clouds and raining back to Earth. The moment the oceans disappeared, the Earth would turn into a vast desert. Go ahead and throw away your umbrella since it's never going to rain again. Wait, what about all the lakes and rivers? Can't we get by with those? Well, without oceans, the world loses 97% of its water. The small amount of liquid left would not be enough to sustain the water cycle. The pools of drinkable water would evaporate pretty fast. In a matter of days, people and most animals would die from dehydration. Plants would have a few weeks before they started decaying in the dry air. Within a few months, forests would begin massive die-offs. And all this dry, dead vegetation would eventually ignite. In a matter of years, most of the world's forests would be burned down. As these huge bonfires sparked all across the planet, the atmosphere would become less and less oxygenated. If there were still humans at this time, the unbreathable air and scorching temperature would wipe us out for good. All in all, the Earth would end up just like Venus, cooked. So why not take a few days off and enjoy a little seaside vacation while you can?
Right now, in the United States, one of the world's largest volcanoes is gearing up to explode. It's known as the Yellowstone volcano. And it's not just any regular volcano. Nope. It's a supervolcano. If Yellowstone decided to erupt, the results would be devastating. But how bad would they be? Is there anything we can do to stop it? Would it affect the entire world? And how would this change our weather? This is What If, and here's what would happen if the Yellowstone volcano erupted tomorrow. Located in Wyoming in the United States, Yellowstone has erupted 3 times in the past 2 million years. This has led some people to wonder whether we should be worried about another Yellowstone eruption in the near future. And by near future, we mean probably in another couple 100,000 years. But instead of waiting so long, why don't we find out what would happen if the eruption took place tomorrow? If you live in North America, there would be virtually nothing you could do to prepare. Now that this supervolcano has exploded, well, first, what makes Yellowstone a supervolcano anyway? Well, apart from it being larger in size, a supervolcano also produces a much more massive explosion. Most of the time, when we think of a volcanic eruption, we think of the hot, molten lava spewing down, covering the surrounding area. Well, while that would happen at Yellowstone, and it is something you'd need to worry about, it wouldn't be the only thing. In fact, the lava pouring out of the volcano might be the least of your worries. Surprisingly, there wouldn't be much of it. At least not as much as you'd expect from a supervolcano. That's because before lava leaves a volcano, it's first known as magma. But in this case, a lot of Yellowstone's magma won't be able to become lava. That's because it will be shot up into the sky, becoming airborne ash particles. And it won't just be any type of ash. These will be tiny, scorching little particles of jagged rock. Now this would affect nearly the entire United States and Canada. Tens of millions of people within 1,000 kilometers of the eruption would die. If you breathed the ash, which would be inevitable in a scenario like this, it would form a cement-like mixture in your lungs, causing you to suffocate. Buildings would collapse as just 30 centimeters of ash is enough to cave roofs in. And you'd still be in trouble even if you were outside that 1,000 kilometer range. Experts say that even the east coast of the United States would be covered with 1 centimeter of ash, which would still be incredibly dangerous to our human lungs. Even parts of Europe would see some ash, maybe a light dusting. And that wouldn't be the only effect they'd experience. Apart from the deadly ash everywhere, the entire world would experience a temperature drop. The ash lingering in the air would block out the sun, resulting in significant weather changes. The global temperature would drop by 10 degrees, an effect which could last as long as a decade. The ash would also affect crops, water supply, and virtually everything else in the western part of the world. So, although you'd probably survive the initial explosion, you'd eventually suffer the consequences of the ash. Whether that means dying relatively quickly or living long enough to experience a colder, harsher world. Luckily, you can take a deep breath of ashless oxygen knowing that something like this will probably never happen, at least not in our lifetime. An eruption like this at Yellowstone would be known as a supervolcanic eruption. A more likely explosion at Yellowstone would be a hydrothermal eruption. This mainly involves a lot of steam and some rocks hurtling through the air. Although something like this would be bad, it wouldn't be nearly as scary as what we're getting here. A more likely eruption at Yellowstone would be a relatively simple lava flow. In fact, since the last major explosion, 600,000 years ago, we've had nearly 50 of these eruptions and 0 casualties.
This is Earth, 1,000 years in the future. Humans are long gone. What happened here? And what remains from our time on this planet? Well, today we're answering, if all humans vanished, how long would it be until Earth erased every trace of us? It's day 1 after every single human on Earth has disappeared. The streets are empty, the cars have stopped, bikes lay abandoned, the music gone silent. Squirrels and dogs and cats run through the city squares, along with the odd police horse. A bold coyote makes its way downtown. On the surface, the cities still look normal enough, minus the traffic and the crowds. Times Square and Shibuya Crossing stand barren, but the lights are still on. Traffic lights beckoning pedestrians to walk. The majority of hydroelectric and nuclear power plants are still operating, though no one is at the wheel overseeing them. Within a week, most will trip a routine breaker that a human supervisor would normally reset, and then the sprawling plants will shut down. Generators kick on in hospitals, their diesel motors keeping the city looking like it normally does, but they'll burn through their backup fuel within 48 hours. Generators running on natural gas will keep running longer. Cities start to go dark. They're still warm because most heating systems are built to run autonomously, but within a few weeks, natural gas compressors and distribution stations stop working properly due to pressure drops or power outages. In the colder parts of the world, the heat starts to turn off. In the warmer parts of the world, the food is rotting. Post-humanity smells. Within a month of humans disappearing, our usual comforts of modern life, electricity, heat, and running water, have mostly stopped working. Humans have built incredible automated systems to give ourselves power, control over the temperature of our homes, and nice warm baths. But guess what? Humans actually still do the stuff, or did the stuff, to keep all those systems running. Cities are blacked out. Wherever it's winter, towns freeze solid. Pipes burst, flooding houses and residential buildings. Fires and explosions are common. Behind the locked doors, it's basically cockroaches. Pets, farm animals, and zoo animals either die from starvation or escape their pens and homes and flood into the wild. Outside, it's pure chaos. Things have gone post-apocalyptic in real short order. Like in Chernobyl, packs of feral dogs stalk the streets at night. There is an exception, though. For cities that built their power grids around renewables, Well, these solar panels keep turning photons into electrons. Wind turbines and hydro keep churning. In Reykjavik, hey, the geothermal is still working. But all complex power systems have fail-safes and breakers that need monitoring and supervision, and without human direction, the major grids shut down, one by one. Within a year, all urban centers are dark and cold and silent. Now, if you were one of the sole survivors who somehow avoided the big vanishing, how would you be doing at this point? Well, there'd still be tons of preserved canned food, fuel for burning, bottled water, lots of shelter because, well, there'd be no one else around. If you knew anything about camping, you'd be just fine. For a while. You could rig up your own local solar panels and keep the lights on. Start farming. Of course, it would be a bit more challenging than usual because, there's no internet to ask, how do I install solar panels? But there'd still be a lot of books to guide the way. You remember books, right? Well, now, whether you had a library card or not, you'd have access to all kinds of critical information, if you could figure out the Dewey Decimal System. Outside of your home or apartment, the rest of the human world would start to slowly decay. The weeds and the riotous power of nature push their way into the human domain. Remember the pandemic? Yeah, those nature is healing videos. Well, most were fake, but now nature is starting to heal aggressively and overtaking the old human world. How long until it erases everything we've built? Well, we'll get to that, but you've probably been wondering, how did we disappear anyway? Now, the way humanity ends will have a lot to say about what actually remains for nature to heal. I've spent a decade YouTubing all the ways the universe could kill us, and there's just so many ways. On one end of the how does humanity die spectrum, it's possible that something out there in space could kill us. For instance, we've been keeping a close eye on the massive temperamental white dwarf star in the binary T Pyxidus system, about 3,000 light years away from us. Scientists estimate that it will go supernova in about 10 million years, which could completely destroy our ozone layer. So, what if we've missed a bigger, closer star that goes supernova without warning? It would hit us with a gamma ray burst so strong that it not only destroys all life on Earth, but also shreds our atmosphere and takes the entire crust off the planet. If we get hit by particles traveling 99% the speed of light, Earth gets sanitized. Or what if we don't spot an incoming asteroid, an interstellar runaway like 3I Atlas rocketing into our system at high velocity? That guy was doing nearly 7 kilometers per second, and if it hit, it was going to do way more damage than the Chicxulub asteroid. And Chicxulub, which nailed Earth 65 million years ago, wiped out the dinosaurs. It incinerated forests, blasted trillions of tons of gas and lava into the atmosphere, and created a nuclear winter. That kind of impact would erase a lot of human achievement in short order, so it's possible an asteroid could disappear us, along with most of our infrastructure. Another option, what if we obliterate our own existence by starting a nuclear war? Yeah, the threat of mutually assured destruction hovered over us during the second half of the 20th century, and humanity still has over 12,000 nukes, which could kill millions in the initial exchange, and then billions with the radiation and the nuclear winter that would follow. But it wouldn't leave the planet looking like this. None of those scenarios would. They would just cause mass destruction. So, what would vanish us? Well, the most likely culprit is a superbug, a bioengineered virus or bacteria released en masse by nefarious actors. bad guys with bad pathogens. This idea has been around since we really started fretting about the end of the world, post-atomic bomb. It was popularized during the height of Cold War Armageddon fears, emerging in sci-fi thrillers like Alistair MacLean's The Satan Bug. It was Star Trek stuff at the time, medical make-believe, but these days, researchers worry that a real Satan bug could be designed by rogue scientists and AI. Microbiologists bumped up against this recently. AI solved a complex superbug antibiotic problem, one that had taken researchers years to figure out, in just a couple of days. And it was just 2 years ago that scientists warned against research into creating mirror-life bacteria. While hailed as a good way to develop targeted, long-lasting drugs, the bacteria could also potentially kill any life on Earth that was exposed to it. Or we could be wiped out by a robotic superbug, tiny, self-replicating Terminator nanobots that disassemble human biology in minutes, leaving behind nothing but molecular dust and goo. Ugh. Either way, a biological superbug or a robotic superbug would have the same result. Every city still standing, every building as we left it. A pristine, museum-quality replica of the human world, with no humans in it, and no one to see it. All of us just gone. So, if humanity vanished, leaving everything we've built standing strong, how long would it be until everything we've ever created just fades to black? The decade after we disappear will be wild. Without maintenance, the world would burn, literally. Without any firefighters, heavily managed forests would be unprotected for the first time in decades. Mega forest fires would rip across the planet, consuming forests and cities in blazes we can't even fathom. Without irrigation, farmers' fields would turn to dust. Massive storms turning former wheat belts into dust bowls and desert. Dams would overtop and burst, flooding valleys that humans have lived in and farmed for centuries. And out of the ash and the dust and the flood, the world of plants and fungus would invade the places where humans once reigned. The first losses would be invisible. All those little waterproofing seals and window gaskets would fray and start to let water and snow into houses. Now, new homes are generally built to last 50 to 100 years, but roofs, as any homeowner can tell you, need to be repaired regularly. Without maintenance, the roofs of residential homes would start to fall in a decade or two. And once that happens, well, then the water gets in and the house begins to rot. Wet drywall equals mold and mushrooms and moss, and then insects burrowing into our most treasured possessions. Within 20 to 30 years, waterlogged houses would start to cave in on themselves. In big downtown condos, whatever's sealing those windows would start to fail around the same time, leading to the constant sound of full-sized glass windows falling from residential towers and shattering on the street below. With wide open windows, then moisture and plants move in. Everything warps and the structure destabilizes. Steel corrodes, rebar expands and fractures the concrete walls. Within 50 years, cheap condos and office towers start to slump over and fall. Soon after that, bridges and overpasses fail. Concrete cracks, particularly in colder climates where the freezing and thawing cycles quickly break it apart at the seams. Steel bridges rust, and without humans to keep up with painting and replacing struts and suspension ropes, suspension bridges collapse in spectacular fashion. Their swaying cables would snap, sending them tumbling into the sea. Now, on the upside, with us pesky humans out of the way, well, Earth's endangered species and fragile biodiversity would see a resurgence. we've seen nature rebound in places where humans have disappeared, like Korea's demilitarized zone, the DMV, thin strip of land where no humans have been allowed since the 1950s. It's now an ecological utopia, bordered by landmines. Within 100 years, most of our modern infrastructure collapses. What remains standing after a century are the buildings that were, frankly, built to last. Often built in the old ways with stone and masonry, government buildings, cathedrals, places of worship, monuments. There's a surprising number of freestanding stone buildings that have survived 1,000 years or more. Of course, they had human hands perpetually repairing them. Some are even older, like the Pantheon in Rome, which has been standing for over 1,900 years. It's an outlier, engineered with a special type of self-healing Roman concrete. But without any human oversight, these marvels of engineering would weather and sag and eventually fall apart. After 1,000 years, every major cathedral and monument would finally topple over. The Statue of Liberty would lie broken. Even the Pantheon's pillars would crumble, its iconic dome cracking and shattering in the dust. City skylines would be gone. The old towers of commerce, the glass and steel monoliths, would have long since rusted and crumpled, every city becoming a pile of rubble. The only buildings that would remain, in large part, are the buildings that previously stood for millennia. Stone temples and funeral mounds like the pyramids, cleanly designed, meant to last for eons. But the land would begin to bury them, the forests growing over them, the sand sweeping over the Sphinx once again. And while you might think, what about plastic? Plastic will last forever. Well, it usually takes 20 to 500 years to degrade into smaller pieces. After 10,000 years, nature would grow over everything. An alien visitor flying overhead would never be able to tell that there'd been a civilization below. But the buildings would still be in some recognizable shape buried beneath the ground. If an alien species had LiDAR technology, well, they could uncover great old structures in the same way that we do. It wasn't that long ago, back in the 1990s, that we realized the insane age of some of the buildings we've left behind in the past, like the ruins of Göbekli Tepe in southern Turkey. The archaeologist who rediscovered the ruins described it as a mound with no traces of prehistoric people visible, no walls. But beneath the soil was the oldest building in the world, built over 11,000 years ago. Similarly, we've found single buildings like the Knap of Howard, still preserved beneath the Scottish peat, a tiny farmhouse over 5,000 years old. So even after 5 to 10,000 years, our work would still exist, but it would be buried. Like the temples of Tikal, the great Mayan temples abandoned to the jungle over 1,000 years ago. When they were rediscovered, the buildings had been completely overrun by the jungle, just the limestone tips of the Mayan pyramids poking out from the hills in the thick forest. But beneath the ground, the buildings and burial sites were still remarkably intact after 1,000 years, and the steps still climbable. And it's not that uncommon. The famous terracotta warriors in China had been hidden in the mausoleum of the first Qin emperor, Emperor Qin Shi Huang, for over 2,000 years when they were found, with barely a scratch on them. It's somewhat fitting that the longest lasting marks that humans leave behind tend to be funeral monuments, gravestones. But time erases everything, eventually. After 100,000 years, even the terracotta warriors and the Mayan temples would crumble. Weathering, erosion, plants, and fungi would break concrete into sand, steel into iron oxide, into soil. Cities would barely be elevated mounds. The places we inhabited, indistinguishable from nature. If you stood on a cliff overlooking Mexico City or Tokyo and gazed out at the world, it would look pristine. No remnants of these cities, just forest and grasslands, jungle. Nature would be completely recovered by now. The sounds of traffic replaced with the hum and the calls of wild animals. Without humans overrunning their habitat or hunting them, formerly endangered species would reclaim their natural footholds. Sumatran orangutans would proliferate across Southeast Asia. Amur leopards, whose population was driven down to less than 200, would hunt in great numbers again across the former Russia-China border. On the African plains, without fences or poachers, the great migrations would become truly great again. Families of endangered black rhinos and our cousins, the mountain gorillas, would thrive and grow. And the California condor would soar over the west coast in flocks once more. The one true legacy we'd leave behind? Our pets. Cats would survive just fine without us, thank you very much. And dogs? Well, they'd be our most impressive, lasting legacy. This is a dingo. They evolved around 5,000 years ago, not from wolves, but from escaped dogs. And these are dingoes 2.0, descendants of the surviving dogs of the Great Vanishing over 100,000 years ago. They hunt in packs just like wolves and African painted dogs, but at heart, they're definitely still our old pals. Now, on the surface of Earth, humanity's best friend would become humanity's last remaining flag bearer. But deep underground, our presence might last longer. Don't forget, we discovered cave paintings dating back 50,000 years or more at sites stretching across the planet. We found pictures of prehistoric life from Europe to Brazil to Indonesia, so there's a chance that our activity beneath the surface would also survive. Places like mine shafts, subway tunnels and their ancient graffiti, weird bunkers like the Churchill War Rooms, or the Svalbard Global Seed Vault and its 675 million seeds. Or the deep geological repositories drilled hundreds of meters underground, created to securely hold our nuclear waste. So yeah, the last remnants of humanity that someone finds might be a seed repository or a nuclear fuel dump. But eventually, even those will cave in. The Earth never stops moving. Over millions of years, tectonic plates will skate over Earth's molten core, subducting humanity's existence with it. Above ground, plants and animals would continue to evolve, and eventually, the next great intelligence would arise. They might be the descendants of our cousins, those endangered orangutans or mountain gorillas. Or they might be orcas, or octopuses, or crows. But eventually, some other species would become smart enough to dig around and invent their own paleontology and wonder, who were these crazy humans who left these fossils behind? Because Earth keeps evidence of everything. Though almost everything will be eventually destroyed by geological activity, our passing will remain for billions of years. We know this because we've found fossils of everything from T-Rex back to stromatolites, which lived over 3 billion years ago. And you gotta imagine we humans would leave some serious fossils. Which means that no matter what happens, Earth will never truly erase all trace of us. Not until the sun transforms into its red giant phase in about 5 billion years. And even then, it's possible that some remnant of humanity, a finger bone or a tooth, maybe yours, will remain buried deep beneath the surface until our planet's last days. Sea levels are rising at an alarming rate. Water rushes to cover streets, quickly swallowing entire cities. Earth is about to become a real-life water world.
Can humans survive underwater? Or would this be the end of life as we know it? Sure, our blue planet is already 70% ocean, but that 30% of land is the difference between life and death. If Earth suddenly became completely submerged, humanity's chances of survival would be slim. Everything would begin here. Scorching heat waves, ravaging wildfires, raging windstorms would hit the planet all at once, causing a heat wave so long and intense it would melt all Earth's ice. And let me tell you, Earth has a ton of ice. 10% of all land is covered with it, from glaciers and ice caps to Antarctica's ice sheet. 12,000 years ago, when Earth was in its Ice Age era, ice covered 32% of all land, so 10% doesn't sound so bad. And the good news is, Earth has a lot of land. Even with all of today's ice suddenly melting, the sea levels would only rise 70 meters. But that would be enough to submerge the coastal cities. Very quickly, the ocean would flood New York, Miami, Vancouver, Rio de Janeiro. Europe would lose London, Paris, and Venice. All of the Netherlands would be gone. The Maldives, Fiji, and the Bahamas wouldn't be such dream vacation destinations anymore. They'd be obliterated. Lagos, Jakarta, Tokyo would be mostly gone too. The entire world would feel this devastating impact. Governments would try evacuating people inland, but with how fast things would be happening, none of these efforts would achieve anything. Rich nations like the United Arab Emirates would jump into immediate action and start building artificial islands off their coast to resettle their citizens. But building these islands would be a delicate, long, and costly process. Any underwater activity would immediately collapse the island, killing the workers and wasting billions. There would be nothing even the richest people could do to outrun the sudden flooding. The water would wipe out 1/3 of Earth's population. After the initial rise in sea level, the world would plunge into chaos. Survivors would raid stores for supplies, fight over housing, medicine, food, and fuel. Forget the evacuation efforts. In this world, everyone would be left to fend for themselves. Anyone with a car would try to escape, causing total blockage of roads and highways. In all that chaos, you'd have a hard time connecting with anyone. Then, the power grids would start failing. You'd be cold, hungry, and scared, running for your life in the darkness. Now, you might think your life has changed forever, but what you don't know is that the worst is yet to come. No, water won't wash your personal data off the internet, but Delete Me can. And that's a good thing, because there's a lot of your info floating around out there. And guess what? Some people are trying to sell it to the highest bidder. They're called data brokers. These are companies that collect personal information like your name, address, your family members, job history, even political views, and sell it. They scrape it from public records, social media, and even other data brokers. You've probably seen their sites without even realizing it. Places like White Pages, Spokeo, Been Verified. Here's the problem. When that info's out there, it can lead to real-life risks like phishing scams, identity theft, or even stalking. That's why I personally use and recommend Delete Me, the sponsor of today's episode. Delete Me makes it super easy to remove your info from hundreds of these data broker websites. They scan the web, find your data, and keep removing it on an ongoing basis. It's already removed my info from 24 sites and found 774 pieces of personal data. And it's not just about me, this helps me protect my family too.
Data brokers often show your relatives' info alongside yours. With a Delete Me family plan, you can protect your loved ones too. So, ready to take control? Well, get 20% off your Delete Me plan when you go to joindeleteme.com/whatif and use code WHATIF at checkout. Well, I guess that was a sponsored segment after all. But we still got to answer some of your questions along the way. And want your question to be featured next time? Well, just keep an eye on the community tab. Now let's get back to the episode. Over 1 million underwater volcanoes lie within the depths of our oceans. The sudden heat wave apocalypse on land could awaken these volcanoes and cause them to erupt. And just like with all What If videos, this would be the worst case scenario. Suddenly, all underwater volcanoes start to erupt at the same time. As they trigger all around the world, magnitude 8 earthquakes would rattle every continent. As skyscrapers crumbled, they'd bury millions beneath the rubble. Here's the thing about underwater volcanoes. They don't just spew out magma. They would also unleash water trapped deep within the Earth's mantle. Scientists think the mantle traps at least double the amount of water of all Earth's surface oceans. If even some of that water was released and added to the already rising sea levels, the land would submerge even more. Before anyone had a chance to recover from the devastating planet-wide earthquakes and rapid flooding, towering tsunamis would sweep already decimated continents. The evacuation zones would become sites of mass chaos and panic. As people fled these walls of water, many would be trampled and die before ever catching a glimpse of safety. Tsunamis travel up to 50 kilometers per hour on land. Unless you're Usain Bolt, there's no hope of outrunning one. And while the tsunamis destroy everything in their way, the water released from the mantle will keep rising. Once sea levels reached 3.3 kilometers, 2 miles, every continent on Earth would be submerged. Only mountain peaks would tower above the water, but getting to them would be difficult. For the most part, Earth would now be a water world. At this point, whatever was left of the world's governments would attempt to form a new government and declare martial law. The mountain ranges would become safe zones, but even military forces couldn't rein in the chaos as civilians hoard food and build rafts for their families. As people were fighting for their lives above water, the New World government would start making long-term plans. They'd start building underwater living units. Of course, these units wouldn't happen overnight. Building underwater cities would take time and collaboration. Soon, these habitats would become humanity's last resort. By day 60, Earth would never be the same. Forests, grasslands, deserts, everything would be gone. Plants that grow in soil wouldn't survive underwater. They'd start to die out, and with them, land animals would die out too. Of course, a lot of them would drown in the initial flooding, but with their food chain disrupted, the remaining land animals wouldn't last long in this new water world. It would be a mass extinction event on a level the Earth hasn't seen in 66 million years. And if you think marine life would be safe, you're wrong. With no land and all the ocean evaporation, there'll be more carbon dioxide in the air. The ocean would absorb that, triggering a chemical reaction that would turn the oceans more acidic. Now, that would be lethal for marine life. Shell-forming organisms like clams and coral would be the first to go. With the food chain disrupted, not even massive whales would be safe. Now, our planet has wiped out species before. It created life and then mass killed it off, not once, but 5 times in Earth's long history.
Each extinction event reshaped the biosphere, erased dominant species, and allowed new ones to emerge. The first time it happened was 445 million years ago, when most of Earth's early life existed in the oceans. It was a time of creatures like trilobites, brachiopods, and early coral reefs. During the Ordovician extinction, Earth suddenly cooled down and then warmed up again. This violent climate swing disrupted ocean chemistry and oxygen levels, collapsing ecosystems. In the end, it wiped out 85% of all species. The most recent extinction event involved a massive asteroid impact. 66 million years ago, the impact of this asteroid caused fallout that darkened the skies, disrupted the climate, and killed off all the dinosaurs. Scientists call it the Cretaceous-Paleogene extinction. And now, it will be our turn to go extinct. Okay, 2 years after the initial melting of the ice caps, Earth would be unrecognizable. At this point, between 70 and 90% of all species would be gone. Of all the people that remained, most would survive by raiding and looting. We'd build boats out of anything we could get our hands on. The most organized and richest groups would move to subsea units. Now, these underwater communities would create fresh water by running ocean water through desalination tank, and they'd bring in air through tubes pumped from the surface. But the good news? The wealthy would leave their yachts behind. Above water survivors would take over these luxury boats, barges, and cruise ships, but these ships can only fit so many people. Survivors would collect rain and boil seawater, but those processes are far too slow to secure enough fresh water for everyone. Dehydration would kill thousands. Barges would band together to create new groups, initiating systems of trade and collaboration between floating communities. Some of these newfound societies would thrive, but as always, bad faith actors would plunge some into anarchy and violence, seizing resources for themselves and leaving the rest to starvation. Even in thriving communities with few medical treatments, diseases run rampant. We'd be forced to create harsh quarantines, abandoning anyone who shows even the slightest hint of illness. Now, at this point, every ship and barge would run out of fuel and float stranded in the ocean. We'd be at the mercy of oceanic storms, and these storms would be much more dangerous on an Earth that's 100% covered by water. Usually the land would weaken the storms as they move inland, but now with no land left at all, these storms would be unstoppable. The air would become dense because of all the ocean vapor. It'd be hot and humid all the time. But not all would be lost. Some communities would successfully farm algae, a nutrient-rich and quickly grown food source. With the majority of the population already lost to flooding, malnutrition, and disease, the few survivors can secure enough resources to sustain themselves. Life on Waterworld Earth would be difficult for a long time. Let's be real, this is an everyone dies kind of scenario. It's likely that the result of Earth becoming 100% water and 0% land would be a near total extinction of Homo sapiens in a generation. In a more positive scenario, a few 100,000 of us would be left to struggle to survive for a generation or two. It's not looking good for us. Even in the most positive scenario possible, Earth would house about 10 million people scattered in small communities all over the world. As humanity continued to live on the ocean, some evolutionary mutations would occur. Some sea communities have already developed these traits. The Bajau people in Indonesia have 50% larger spleens than you and me, providing them with a larger supply of oxygenated red blood cells and the ability to free dive to depths of 70 meters for as long as 13 minutes. Yeah,
That isn't the only adaptation we'll see. The Munkin people in Thailand have adjusted their eyes to see underwater better. With better underwater vision and air supply, humanity would become advanced marine hunters, spearfishing successfully enough to feed their newfound families. But even with these evolutionary mutations, humanity can't survive long enough to fully adapt to the ocean. There won't be enough survivors to repopulate. The infant mortality rate would skyrocket due to malnourishment. Humanity's predisposition for violence will wipe the rest out. Sorry, I tried to stay positive here. Even though we came from the ocean, we really only evolved for the land. And while it's unlikely that all Earth's ice will melt in this short time, it is happening. 20,000 years ago, sea levels were 120 meters lower than they are now. Eventually, all glaciers and ice caps will melt. It'll just take us about 5,000 years to get there. A new moon has suddenly appeared near Earth, except it's not orbiting our planet, it's orbiting the moon. What? A moon having its own moon? How did this mini moon form? Is it here to stay? And how would this affect us on Earth? Okay, before we throw ourselves into the orbit of our planet's largest natural satellite, let's take a look at how our moon came to be in the first place. To do that, let's step back, about 4.5 billion years back, to one of Earth's most impactful moments. Scientists theorize that in the early years of our solar system, there was another planet in our cosmic neighborhood, known as Theia. And even though this planet could have been about the same size as Mars, we don't have much evidence to prove it because, well, Theia no longer exists. That brings us to the Great Impact hypothesis. According to this theory, Theia and Earth were both in orbits that doomed them to a head-on collision. And when these massive celestial bodies bumped into each other at high speeds, the impact was, well, as the name suggests, quite great. Enormous amounts of material were ejected from both planets, but all this debris didn't just drift off into outer space. Instead, it formed a dense ring of molten rock, dust, and gas around Earth. And over the course of a few million years, this material lumped together under the forces of the planet's gravity, merging into one single object, an object we know today as the Moon. So, if this is the story of how our gravitational companion came to be, does that mean we should be bracing for the Great Impact Round 2? Well, that's not the only way moons can form. And by moons, I'm of course referring specifically to submoons or moon moons, which are all just different ways of saying the moon of a moon. Still with me? Okay, good. Beyond the Great Impact hypothesis, which requires millions of years to play out, there are faster routes to acquiring a moon. Some moons are fully formed objects that are captured or pulled in by the intense gravitational forces of a celestial body. Take Neptune's moon Triton as an example. Theorized to have been a large icy body in the Kuiper Belt region, it may have been captured by Neptune's gravity after a close encounter. This massive gravitational disturbance could have ejected the object from its original orbit and pulled it into its own. Over time, Neptune's tidal interactions forced Triton's orbit to go from long and elliptical to nearly circular. And in case you're wondering how this theory came to be, well, it's because Triton, unlike other large moons in the solar system, orbits in retrograde. And no, that doesn't mean its vibes are off, like when Mercury is in retrograde. It just means that it orbits in the opposite direction that the planet spins in. Okay, in order to avoid the mess of a giant collision, let's imagine that our own moon's moon was a captured object, like Triton. Maybe it was once an asteroid,
passing just close enough to Earth to avoid a collision, and even closer to the Moon to find itself trapped in its orbit. This would make for an incredibly delicate gravitational disruption, big enough to be locked into the Moon's gravity and small enough not to disturb the Moon's orbit around Earth. The object would need to be a bit of a Goldilocks. One study suggests that in order to maintain a stable orbit around our Moon, this object would have to be no bigger than 1 kilometer in diameter. And even if this asteroid were to succeed in becoming a moon, well, it wouldn't stay one forever. It would be constantly tugged and pulled in different directions by the tidal forces of both Earth and the Moon. That would mean there'd be a chance of it getting ejected from its orbit or colliding with the Moon. So its entire lifespan as a moon might only end up lasting a few years or decades at most. During this short window of time, the moon would have little to no effect on us back here on Earth. Well, physically at least, but that wouldn't mean that it wouldn't become an object of endless fascination to us. Throughout history, the Moon has been a source of inspiration for myths, legends, and folklore. The sudden appearance of a small moon swinging around it would inspire a whole new wave of stories, art, and no doubt plenty of conspiracy theories. But beyond the stories we'd get to tell future generations of our moon's moon, scientists would have an opportunity to study a celestial phenomenon like nothing we've ever seen before, and so close to home. Observatories and telescopes could focus on this tiny object to study the ways that different objects interact with forces of gravity. This would help us collect data and predict similar events happening in far-reaching parts of our cosmos. But mostly it would give you something new and exciting to gaze endlessly at in the night sky. Until one day when it may appear to drift away back into the depths of space or careen downward into a rocky impact. And if you weren't keeping a constant eye on it, well, you better hope someone was, because amid the tidal tug-of-war between our planet and the Moon, there's a chance that the moon eventually collides with us here on Earth. In this event, the moon would behave just as you'd expect any asteroid to act. Headed toward Earth, it would enter our atmosphere and then begin to generate intense heat as it encounters the friction of the air in our atmosphere. Considering its small size, there's a good chance it would likely break apart before making impact. But if it stayed intact, well, that could spell trouble for us. Traveling at an average speed of 72,000 kilometers per hour, this asteroid could smack down right on top of your city. Now, the amount of energy released by an impact like this would be equal to thousands of megatons of TNT. I wonder what would happen if a much bigger object came crashing down onto Earth. How much worse could things get?
Okay, it's time to switch things up a little. What if Earth suddenly shrunk to be the size of the Moon, and the Moon expanded to be the size of Earth? How would you be able to fly on this tiny Earth? Why would you never see the Moon again? And could humans on Earth survive this catastrophic switch? This is What If, and here's what would happen if the Moon and Earth switched sizes. Okay, before we see what happens if we switch things around, here's the baseline. If Earth shrunk, everything on Earth would become smaller, but in proportion to each other. Earth would have the same land, continents, mountains, oceans, crust, and iron core, only shrunk down to the size of the Moon. And just to keep it simple, we'll call this new Earth Little Earth, and the larger moon would be the Big Moon. Little Earth would be smaller, but humans, animals, and plants would stay the same size. So buckle up, it's about to get very crowded. Our regular-sized Earth is about 4 times larger than the Moon, and it's 80 times heavier. But not today. Today, these celestial bodies are in for a big switch-up. Little Earth would now become a moon of the Big Moon, and it would start to orbit around it. But I'll get back to this a little later. First,
let's talk about gravity. It would be massively different. For any celestial body, the force of gravity depends on both mass and radius. Little Earth's radius would be around 1/4 of what it used to be, but its mass would only be 2% of a regular Earth. This is a massive change that would definitely make your life harder, or lighter. I mean, on this little Earth, you would feel lighter because gravity would only be 27% of Earth's original gravity. If you were 70 kilograms on regular Earth, well, now you'd only weigh about 19 kilograms. That's good news for me because I'm really bad at working out and dieting. With this new low gravity, moving around would be way more fun. You'd feel like Neil Armstrong bouncing around on the moon, only you'd still be on Earth and you don't need a spacesuit. Places that used to be far away would suddenly become so much closer. New York to Paris, well, it's no longer 6,000 kilometers and 7 hours away. Now it'd just be 1,500 kilometers and less than 2 hours to fly. It would take less fuel to get there, but also less fuel for aircraft to launch into the sky thanks to low gravity. Now, it's great to weigh less, float around, and get to Paris in no time at all, but I'm afraid there would be some bad news. We humans evolved on a planet with much higher gravity, so we're not adapted to living in a low-gravity environment. Over the course of just 6 months out in space, astronauts can lose 13% of their muscle mass. Now, being in low gravity wouldn't be as bad as being in zero gravity, but your body still wouldn't like it. Your spine would break down and lengthen, and you'd have constant back pain. Your muscles would weaken, and with less gravity, your body's fluids would move up the body more easily, resulting in what some scientists call a puffy-faced bird leg syndrome. Yeah, it's exactly what it sounds. You'd have tiny legs and a swollen face, and your eyes would get damaged. Meanwhile, the big moon would now be as wide as Earth and would weigh about 2/3 as much as the original Earth. Well, guess what? Its gravity would increase by a lot, too. Right now, the moon's gravitational pull is only 1.62 meters per second squared, but with this new size, its gravitational pull would become 5.96 meters per second squared. That's like 60% of regular Earth's gravitational pull. Just because there's no life on the moon that we know of, it doesn't mean it wouldn't be a big deal, because the gravitational pull from the new big moon would create havoc with something else: Little Earth's tides. On the regular-sized Earth, the tides are 1 meter high, give or take, but if the moon suddenly became much heavier, it would pull more violently on the surface of Earth. What used to be a tide would now be a tsunami. Say goodbye to coastal cities like New York and Venice. They'd be flooded and wiped out. Millions of people would die. And that's only the beginning. The gravitational force from Big Moon would pull so hard on Little Earth that it would deform the Earth's surface. Cue massive earthquakes and extreme volcanoes. This is because gravity would be acting on Little Earth's molten core, similar to how Jupiter causes volcanoes to erupt on its moon, Io. Now, remember I said you wouldn't need a spacesuit on this new Little Earth? Yeah, forget that. You definitely need one. You're able to survive without one on Earth because our planet has a wonderful, thick atmosphere. It has oxygen for you to breathe, and it protects you from the sun's harmful radiation. But on the new Little Earth, well, we're going to lose our atmosphere, and this would happen really quickly for two reasons. The first and most immediate one is gravity. Regular Earth's gravitational pull is strong enough to hold the atmosphere in place, but with a sudden drop in gravity, the atmosphere would start to drift off into space. Big Moon might actually pick up some of these gases, and who knows, maybe this gray rock would become the newest, most livable place in the solar system. Even if Little Earth held on to a little bit of its atmosphere, there's a second problem that would hack away at it over time. With its smaller size, Little Earth would cool more rapidly. Over time, it would lose all the heat from its molten core. That's what happened to the moon when it formed 4.5 billion years ago. Back then, it was molten too, like Earth's. Maybe you're thinking, what's the big deal with losing our hot molten core? I'll tell you. The outer part of the molten core is what gives our planet its magnetic field. Earth's magnetosphere also helps to hold the atmosphere in place. Without a magnetosphere, solar winds would strip away the atmosphere. Of course, losing all of little Earth's atmosphere would mean you wouldn't be able to breathe, and as the atmosphere is slipping away, the temperatures would become extreme, like a desert. During the day, it would get extremely hot, and then at night, the temperatures would plummet. Little Earth would likely hold on to its ice at the poles, just like Mars did, but all the liquid water from our oceans and lakes would boil away. And that would pretty much be the end of life on Little Earth. Without an atmosphere, you'd be exposed to so much radiation from the sun that even if you managed to survive this far, you'd be suffering cancer and cataracts. Your nervous system would get fried too. While Little Earth would lose its atmosphere pretty quickly, our magnetic field would take longer to disappear. It took about 200 million years for the moon to lose its once existent magnetic field. Over those millions of years, there'd be another major change on this new Little Earth, and I mean major. Our Earth would stop being a planet. To explain this, I need to roll back a bit. The moon is tidally locked to Earth. By that, I mean the moon takes the same amount of time to make one rotation on its axis as it takes to do one revolution around Earth. Because of that, one side of the moon is always facing our planet. In our new scenario, after millions of years, Little Earth would eventually become tidally locked to the big moon. At first, the big moon would make Little Earth slow down. After millions of years, this Earth-Moon system would reach equilibrium. Only now, Little Earth would orbit the big moon, and we would always face this big moon with one side. Well, that would make Big Moon a planet, and Little Earth, well, we'd be Big Moon's moon. With tidal locking, though, one half of our planet would never see the big moon in the sky. Are you ready for another mind-blowing change? Well, the length of a day on Little Earth would no longer be 24 hours. It could last as long as a month. You'd have half a month of darkness, followed by half a month of daylight. On the bright side, all-night raves and pajama parties would last a really long time. Oh wait, at this point, you'd be long gone thanks to the extreme temperatures, volcanoes, earthquakes, and even more extreme radiation exposure. But what about Big Moon? Well, since it was already tidally locked to Earth, that tidal locking would stay in place even after the switch. Now both would be tidally locked to each other. Okay, you know what? We're going to stay positive and let you survive all the catastrophic events on Little Earth. Somehow. You'd still be struggling to breathe in a thinning atmosphere. Your body would be taking a beating from the low gravity, temperature extremes, radiation, earthquakes, volcanoes, tsunamis, you name it. Your life on this Little Earth would be miserable. But on the positive side, the big moon would look awesome up there in the night sky. It'd glow 4 times as bright as before, and you'd get to see total solar eclipses much more often. With all the problems on Little Earth, Big Moon would start looking like a much more attractive place to be, at least in a couple of ways. For one, it would have more gravity than Little Earth. Plus, it's sitting in the Goldilocks zone in terms of distance from the sun, so if we moved there, we'd get the same amount of solar energy as we're used to. The two big problems? Big Moon still lacks an atmosphere, and there's no liquid water. So if humanity, or whatever was left of it, wanted to settle on the Big Moon, well, we'd have to build an atmosphere for it. One way we could do this is to break the Big Moon's crust to release gases from underneath it. And fun part, we'd do it with nukes. With the new higher gravity, the Big Moon would have a better chance of holding on to this new atmosphere. Then, with a basic atmosphere in place, our next step would be to get some water out of the water ice at the moon's poles. The regular-sized moon has about 6.6 billion tons of water ice at the poles. But of course, with the new big moon's size, there would be several times more water ice than before. After freeing up the water, plants could be introduced to produce more gases and create some oxygen. The first steps toward a moon base would be in place. But how would we transport supplies to Big Moon from Little Earth? Well, one bit of good news is that with Little Earth's lower gravity, it'll take a lot less fuel to launch a spaceship to the new moon. We could use Starship technology to make a moonship to establish a settlement on the moon. A huge gas giant suddenly appears in the sky. You look up and wonder. It's beautiful and terrifying. The second that Saturn replaces our moon in its orbit, Earth would just as suddenly stop being a planet. We would become a moon. Yeah, scientists would need to reclassify Earth. Well, that is, if any scientist or any humans at all could survive this planetary switch, because Earth's days would now be numbered. This is the first few minutes of Earth becoming a moon of this enormous gas giant. But before we get into what happens when Saturn captures our home planet with its unforgiving gravitational grip, well, let's talk about the sheer size of this massive giant. Our moon, the moon, has a radius of 1,740 kilometers. That's just over 1,000 miles. And it's less than 1/3 of the width of Earth. It orbits Earth at a distance of about 384,000 kilometers away. Now, to give you an idea of how far that is, well, you could fit about 30 more Earths between us and the moon. Now, if the moon were suddenly to be replaced by Saturn, it'd be pretty hard to miss. Saturn is 33 times wider than the moon. It would dominate the sky, and the rings would make it even bigger, more spectacular, reaching the edges of the horizon. The scale is enormous. Saturn's rings stretch 282,000 kilometers out from the planet. So they'd be reaching out to us, their edges halfway between Earth and where the moon once was. But Earth would be sitting around Saturn's equator, so you wouldn't see these majestic rings the way we see them in outer space right now. Instead, from down here on Earth, they look just like a thin band. Because despite their incredible width, they're only about 10 meters thick. Now, just because Saturn is a gas giant and made mostly of hydrogen and helium, it doesn't mean it's light and fluffy. Saturn is the second most massive planet in the solar system. It's gigantic and heavy. This gas giant is 95 times more massive than Earth. And remember, Earth is 81 times more massive than the moon. So, according to my calculations, that would make Saturn 7,700 times more massive than the moon. And, of course, you know what massive objects have, don't you? Enormous gravitational pull. Yeah, the moment Saturn appeared in the sky, it would start pulling our planet toward itself. Just like the moon pulls at Earth's oceans and causes tides, well, so would Saturn. But on a scale that would be hard to imagine. The gravitational pull would be thousands of times that of what we're used to. These extreme tidal forces would create enormous bulges in the oceans and seas. The tides would run out to sea like raging rivers and then rush back as waves hundreds of meters high. Ships would be left stranded on the ocean floor and then smashed by the returning water. Cities by the sea would be drowned, decimated. And those gravitational forces wouldn't just be pulling on the Earth's surface. They'd be tugging at land, too. Earth's surface might seem sturdy to you, but it's actually quite delicate when it comes to planetary forces. Every fault line would be stressed past its breaking point. You'd be running from earthquakes that would spread everywhere, and from erupting volcanoes spewing toxic ash and gas up into the atmosphere. There'd be mega tsunamis and mega quakes. Cities would be shaken until they were nothing but rubble. And if any emergency services were left after that, help would not be on the way. We're not going to get rid of you that easily. Somehow, you survived this initial chaos, all so that you could witness Earth transforming from our familiar stable planet to the unstable moon of an invading giant. In the first minutes of Saturn replacing the moon, all those eruptions and mega tsunamis would be tearing Earth to pieces. So enjoy the view if you can, because things are going to get a whole lot crazier and deadlier. Again, because of Saturn's enormous mass, Earth would immediately start to be pulled away from our usual trajectory. Like I said, Earth wouldn't be a planet anymore, it would be Saturn's moon, and it would slowly change course and fall into an orbit around Saturn. But it wouldn't be like one of Saturn's usual moons, like Titan. No, Earth would be in a death spiral, getting pulled closer and closer to the gas giant. Speaking of Saturn's moons, you see that gray rock growing in the sky? That's Dione. And yeah, it's bad news for you. Dione is no joke. It's Saturn's fourth largest moon, and it orbits the gas giant at about the same distance as the moon orbits Earth. And don't think you're catching a break in this episode. Dione is on a collision course with Earth. Yeah, Dione is just about 1/3 the size of our moon, but that's still a pretty big rock that's about to hit our planet. Remember the Chicxulub asteroid that wiped out the most gigantic animals that ever roamed the planet? Yeah, well, that dinosaur killer was about 10 kilometers in diameter. Well, Dione is 100 times larger than that. Getting nailed by this moon would hurt. A lot. At first, all you'd notice would be another new moon rising. It would look small and insignificant, but it would grow fast. And that means Dione is getting closer and closer, until eventually it would reach Earth's oxygen-rich atmosphere and ignite into a massive fireball. Yeah, our entire sky would be on fire. And as it falls toward Earth, Dione would pick up speed. Its normal orbiting velocity of 10 kilometers per second would ramp up, accelerated by Earth's gravitational pull. This dense rock moon, 1,120 kilometers across, hitting Earth's surface, would punch a hole deep into Earth's crust and instantly create a country-sized lava crater. At impact, the energy that gets released would send out a fiery shockwave, sweeping around Earth at thousands of kilometers per hour, incinerating everything in its path. Earthquakes would spread out around the world from the impact crater, leveling cities, forests, even mountain ranges. The blowback from the impact would eject a blob of molten core up into the sky, falling back to Earth as searing hot lava rain. If the impact was at just the right angle and velocity, well, the blob of molten rock would be rocketed into orbit to become another moon. But it would be a moon to a very different Earth than we know today. This new Earth would be a fiery, uninhabitable ball covered with red-hot magma oceans. Every single living thing would be killed. The surface of Earth would be sterilized. Some extremely hardy bacteria living in warm volcanic plumes deep at the bottom of the ocean might be the only survivors, and even then, only for a short time. Otherwise, all life would be gone. But hold on, how about some good news? Well, I don't know what your definition of good news is, but at least Earth would be safe from most of Saturn's other moons, especially the largest one, Titan. Titan orbits Saturn at a distance of 1.2 million kilometers, which is 3 times the distance that our moon is from Earth. So if Saturn became our new moon, well, Titan would still be pretty far out in space. Which is fortunate because Titan is 5 times as big as Dione. It's bigger than Earth's moon. A collision with Titan would be a planet-smashing game over for us. But what if Earth managed to scrape past Dione and continue our journey toward Saturn? Well, it wouldn't exactly be smooth sailing from here on in. We'd be heading for a disaster unlike anything Earth has ever experienced. In the unlikely event that you were still alive, well, you'd witness Saturn getting bigger and bigger in the sky, blocking out everything else. Quite a sight. But just because we snuck by one moon doesn't mean we're out of immediate danger. The Saturn has 274 confirmed moons in its orbit, more than any other planet. Some, like Titan, are as big as planets themselves, but others are just 20 kilometers across, like Pan. Lucky for Earth, if Saturn replaced our moon, there'd be just 11 of these moons left in the distance between the gas giant and us. But yeah, Earth would be drifting through an obstacle course. More good news, though, most of these moons are small, and impact would only be slightly catastrophic. But as Earth passes the 300,000 kilometers away from Saturn mark, we'd be in danger of smashing into Tethys, its 5th largest moon. A collision with Tethys would be similar to a collision with Dione and just as destructive. Even if we snuck by with a close scrape with Tethys, Earth would be rocked by new, even more destructive tidal forces. A close flyby would cause whatever was left of our oceans to slosh around. Waves hundreds of meters high would smash ocean shores. At 180,000 kilometers away, we'd be getting close to another moon of Saturn, Venus, a small moon, a mere 392 kilometers wide. An impact or scrape with Venus would further agitate our atmosphere and stress the surface. It might even tear a strip off the atmosphere as it glided by. It's hard to imagine anyone still alive on Earth's surface at this point. The sheer mechanical destruction from earthquakes as the crust is stressed and being pulled by increasing gravitational forces of Saturn would have leveled every structure, thrown up new mountain ranges in a matter of minutes, and turned our seas into boiling water. Something orbiting in space might have a slim chance of making it through all this in one piece, like astronauts trapped on the International Space Station, pulled along for the ride. If they were lucky enough to avoid being crushed by a passing moon or slingshotted into space by gravitational forces, they'd be the only humans left to witness this unprecedented planetary event. Imagine peering out the window of your space station and watching as Saturn's rings get closer and closer. And then, suddenly, you're in them. From afar, the rings of Saturn look ethereal and airy, but the reality is that Earth would be plowing through trillions of chunks of ice and rock. Some the size of dust, others huge boulders. As shards from the rings begin to hit Earth's atmosphere, they'd ignite and turn into flaming meteors. But down on Earth's surface, there'd be no one left to watch the most spectacular meteor shower ever. From a distance, it would look like Earth was a giant eraser, rubbing out an Earth-sized section of the rings. Earth would clear out huge swaths of ring debris and fling others out of their orbit, leaving a trail of flowing dust, rock, and ice. By this point, even a surviving space station would be pulverized, being hit by thousands of ice chunks as it passed through the rings. Nothing humans have ever built for space exploration could survive that. As Earth gets to the 120,000 kilometer range, well, then its trajectory would start to resemble a true orbit. As Saturn's immense gravitational force continues to pull on Earth, it would swing around the massive gas ball, and as it did, it would sink into darkness for hours at a time, thanks to Saturn's enormous shadow. But this cozy orbit wouldn't last very long. Alright, about 3 days into this nightmare, Earth would be at a distance of 71,000 kilometers from Saturn, and it would be approaching a force even greater than crashing through Saturn's rings or colliding with one of its moons. Earth would be reaching its Roche limit with Saturn. The Roche limit is the zone where the gravitational and tidal effects of a large object are powerful enough to overcome the gravitational forces that hold a smaller object together. In this case, Saturn's gravity versus Earth's will hardly be a fair fight. Saturn is just so much more massive than Earth. Like we said at the beginning, 95 times more massive. The gravitational forces holding Earth together in its spherical shape won't be able to resist the force of Saturn's gravity pulling on the side of Earth that's facing Saturn. At this point, so close to Saturn, Earth would literally be pulled apart. Within hours of drifting past its Roche limit, Earth would be ripped into billions of pieces of floating space debris. Some of those might clump together, forming new, smaller objects, but most of them would spread out and turn into a thin band of rocky shards orbiting Saturn. Sound familiar? Yeah, Earth would end up yet another majestic ring of Saturn. That's actually how we theorize the rings forming in the first place, as remnants of small moons or asteroids pulled apart by Saturn as they crossed their own Roche limit.
What if the flat earthers were right and the Earth was, in fact, flat? How would gravity work? Would we still have time zones? Change of seasons? Would the conditions for life here on Earth exist at all? This is What If, and here's what the Earth would look like if it was flat. First of all, forget about walking to its edge. Gravity would simply not let you. Wait, would gravity even be possible on a flat Earth? The answer is yes, of course. The force of gravity is what keeps our planet, or any other planet, together. It's what forms a planet in the first place. In the case of a pancake-shaped Earth, the force of gravity would pull you to the center and would become stronger as you tried to walk away from it, pulling the top of your body backwards. It would feel as if you were climbing a hill that was getting steeper and steeper and steeper. By the time you reach the edge, down and behind you would be the same direction. Sound weird? How about water being sucked into the center of the Earth? Or diagonal trees growing in the opposite direction of gravity's pull? And then there's the sun. How would a flat Earth behave in space? One flat Earth theory is that the sun revolves around the Earth, not the other way around. What if the sun orbited the Earth just like the moon does? In that case, you'd never suffer jet lag because there'd be no such thing as time zones. The sun would light up both the top and the bottom of the planet. This would mean constant light, no day and night cycle. Also, no seasons or solar eclipses. The sun itself would have to be much smaller, otherwise it would burn the Earth to a crisp. It would probably fry the planet anyway, as there would be no geomagnetic field to protect Earth from its radiation. The geomagnetic field is generated in the solid core of the Earth and keeps our atmosphere from escaping. Without it, cosmic rays would bombard our bodies, causing everything from cancer to DNA damage. The oceans would escape into space, and so would the air and all our oxygen. But let's assume that a flat Earth had an alternative to our magnetic field. This way you'd still be alive to notice some of the strange flat Earth effects. Like your shadow. Say you had a friend just as tall as you, but they lived 1,000 miles away. On a sunny day, your shadows would be the very same length. Because unlike here, on a spherical Earth, the sun's rays would hit both of you at the same angle. And if you two were to meet up, traveling would turn out very different. Let's take a map introduced by the Flat Earth Society. Yeah, the one that shows the Arctic at the center and Antarctica as an ice wall around the edges. In this world, it would take you 32 hours to fly from Australia to Argentina. Did we mention there'd be no GPS? Satellites wouldn't be able to orbit a flat Earth, leaving humanity with no navigation and no synchronized time. This means no ATMs, no credit cards, no high-speed stock market transactions. On the bright side, with a good pair of binoculars, you could see Dubai's Burj Khalifa from any part of the flat world. But let's be honest, you don't need to build your own rocket to see that the Earth is not flat. The evidence is all around us.
Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year, and it accounts for 4% of the 9 inches of sea level rise that's happened so far. Some scientists are predicting that the whole thing might melt in decades rather than centuries. But we don't even have a few decades to hang around, let alone centuries. So I'm going to show you what happens if it melts a whole lot sooner, in seconds. In just a few seconds, Thwaites has melted and flowed into the Southern Ocean that surrounds it, and from there into the Indian Ocean, the Atlantic, and the Pacific. Sea levels rise by 60 centimeters around the world. The streets of San Francisco are getting flooded. Miami and New Orleans are also rushed with water. But what's going on? Why did this glacier crack and break away from the rest? Well, there's something going on underneath. Beneath Thwaites is a massive river flowing fast. Melted ice from the iceberg is feeding it. This is happening thanks to geothermal energy from the Earth's molten interior. The melting process starts off slow, but eventually huge chunks of ice break off. This starts a chain reaction, causing more and more ice to break off and melt. And there's more to it than just one river. A whole world of mysteries lies beneath the ice of Antarctica. But before I take you to that fascinating underworld, I want to tell you about why Antarctica is so important. It's an ice sheet covering an area of 14 million square kilometers, with an average thickness of over 2 kilometers. Just for comparison, that's 1.5 times the area of the United States. That is a staggering amount of ice, 25 million cubic kilometers of it. It's 90% of all the ice on the globe, and locked up in that ice is 60% of Earth's fresh water. Now, unlike the Arctic, where the ice is floating on water, there's land beneath the ice in Antarctica. You don't think about it because 98% of the land is covered with ice. And that's not all. 1.5 million square kilometers of ocean is also hiding underneath this ice. And when all this ice melts in a few minutes, sea levels are going to rise an astounding 70 meters. We'll see what this epic meltdown does to Earth in a bit. But first, I want to show you the bizarre creatures we're discovering inside this frozen landscape. As you explore this uncharted territory, you'll get a peek at the ocean floor, and just above you, you'll see the underside of the ice. Here, you'll find a type of marine life called anemones. These tiny little creatures are burrowed into the underside of the ice. You'll also find some other small fish and crustaceans. The anemones you find are going to be very different from what you'd find normally in the ocean. They're a new species with an unusual trait. See, anemones usually stay rooted to a single spot, kind of like a plant, but these Antarctic anemones wriggle about in the water. Scientists are still figuring out where they're trying to go. Okay, almost nothing grows in that cold darkness, right? So, what are these creatures eating, and how are they surviving? Well, it's probably little bits of plankton and poop ferried in by ocean currents, but they're also eating something that's super weird and kind of gross. It's the ocean equivalent of rotting food in the back of your fridge. These creatures are eating millions of year-old rotting skeletons, bodies, and ancient bacteria that were around when Earth was much warmer. Ooh, watch out! A few more massive glaciers are about to break off. As the neighboring glaciers to Thwaites separate and melt, more water pours into the oceans. Worldwide, sea levels rise another 2.5 meters. Cities on the east coast of the United States are covered in water. Boston, New York, Miami, millions of people are affected. Even as cities are getting submerged, something bizarre would be going on right off the coast of Antarctica. Close by, the sea level would actually be falling as all this ice was melting, while the sea level further away would be rising. Now, why would this strange event be happening? Well, remember, the Antarctic ice sheet is enormous. It weighs a mind-boggling 24 billion megatons. So it exerts its own gravitational pull on the surrounding waters, which raises the sea level nearby. But when the ice melts, the power of that gravity is gone, so sea levels nearby fall, just as they're getting higher elsewhere. Over in the east end of Antarctica, the Denmark and Scots glaciers have melted. This adds another 1.5 meters of water to our oceans. Now, at a 4-meter rise, the United States is now losing national monuments. The Jefferson Memorial is underwater, Fenway Park is submerged, major coastal cities around the world are also flooded. Shanghai, Lagos, Mumbai, Jakarta, ports are flooded and destroyed. And all that salty water is flowing into farmland and destroying our crops. Even worse, underground aquifers that give us drinking water are now contaminated with saline spilling over from the ocean. What's scarier is that the contamination runs deeper than just salt. The Antarctic ice carries bacteria that have traits that are dangerous to human beings. Some of these bacteria cause infections, and they're linked to diseases like cystic fibrosis. But it gets worse. They have an even more deadly superpower. They're resistant to the antibiotics we use to treat diseases today. If they exchange parts of their genes with the bacteria of our world, the resistance to drugs will only grow and spread to even more bacteria. At this point, we humans would be toast. We'd no longer be able to fight off bacterial infections. Not good if we're drinking contaminated water. But like any Hollywood villain, these bacteria also have a good side. They can help us create new and better antibiotics. They can help clean up toxic waste sites and maybe even be part of a new biodegradable alternative to plastics. As more and more ice breaks off and melts, other ecological systems are getting thrown out of whack. For one, the melting ice is changing the way ocean currents flow. Before all this ice melted, the water in the oceans moved around in a very particular way. Dense, salty water sank to the bottom of the ocean floor, pushing the less dense water up to the surface. Through this movement, the water acted like a giant conveyor belt, transporting heat and nutrients from one place to another. This is a key factor for the survival of marine life. Now, with fresh water from melting glaciers entering the picture, the water at the ocean's surface becomes less salty and dense and doesn't sink down as far. It's like our ocean conveyor belt has been jammed up. It's no longer able to move heat around from one place to another. Scientists warn that the melting of the Arctic will mess with the warm Gulf Stream. They're still figuring out how an Antarctic ice melt will change our climate. Under some circumstances, for instance, if icebergs broke from the Antarctic and melted further away in the Atlantic, the changes in ocean circulation could bring on an ice age. But if the melting primarily caused sea levels to rise, well, we'd probably just end up with a warmer Earth. And it's not just heat patterns that we need to worry about. Breaking the oceanic conveyor belt means problems with the movement of nutrients from the ocean floor to the surface. These nutrients are important for the growth of phytoplankton, tiny algae at the bottom of the ocean food chain. They may seem small and insignificant, but they're the bedrock of life in the ocean. They provide essential nutrients to marine life. But not all phytoplankton would suffer the same fate. For the phytoplankton around Antarctica's waters, the melting ice would provide iron and give them something rich to feast on. In fact, this event might lead to a temporary massive algae bloom as the waters are flooded with nutrients that were previously buried in the ice. The growth of the phytoplankton might be a good thing because at least they'll absorb a little carbon dioxide. The Earth will need that. Why? Well, because all this ice melting is going to make the planet a lot hotter for several reasons. First, ice helps keep Earth cooler through its super reflective surface. It's very effective at bouncing sunlight away from Earth's surface, which helps keep things cool. But once it's melted, that's a different story. With glaciers melting and the water warming, the activity of microscopic fungi in the water is also picking up. Just like dead leaves decompose in forests, microscopic fungi act on dead matter in the oceans, decomposing it and releasing carbon dioxide. Warmer oceans mean more dead matter gets decomposed, leading to more carbon dioxide being released. Now, on top of this, the melting glaciers create a layer of fresh water on top of the salty ocean water. This causes the oceans to be less efficient at removing carbon dioxide from the air, again, adding to the warming. And now, the rest of Antarctica is breaking up into humongous chunks and melting rapidly. Water from the melting ice pouring into the oceans. As the ice melts, something amazing is revealed. A natural wonder that's been hidden for millions of years. An enormous canyon system, 100 kilometers longer than the Grand Canyon. It's the deepest canyon on Earth, running 3.5 kilometers below sea level and stretching all the way from the interior to the coast. And now you can also see the 15-million-year-old Lake Vostok, the 6th largest lake in the world by volume. And good news, with all the ice melted, you can picnic there. If you're still in the mood to picnic after everything the Earth is going through. Plus, you might want to stay away from the microorganisms living in the waters of Lake Vostok. They've been evolving there, isolated from the influences of our world for 15 million years. Who knows what they could do to your body? But there's no time to admire the canyon or peer at Lake Vostok because sea levels are rising, higher and faster than before. You're witnessing the last and most dangerous stretch. Every last chunk of ice is melted. Sea levels have risen over 70 meters. This rapid rise has caught people by surprise. 40% of the world's population, over 3 billion people, live near a coastline. And the vast majority of them have drowned as Antarctica's ice has melted in a matter of minutes. The entire Atlantic seaboard, including huge chunks of the United States, is gone. submerged underwater. People in skyscrapers as high as 23 stories are forced to race to the rooftop in a desperate bid to survive. Parts of California are transformed into bunches of little islands surrounded by water, and other parts of the state are completely gone. London, Paris, Venice, and every major coastal city we know and love is underwater. Millions of people are displaced, injured, or potentially dying from this catastrophic event. Anyone smart enough to jump in their car and flee inland as the water first started pouring onto land may have escaped with their lives if they could get to higher ground, but those are only a lucky few. Governments are in a panic, deploying emergency operations. They know that almost everyone on the coast is drowned, but maybe there's a way to rescue desperate people on top of skyscrapers. But with so many people affected, are there enough helicopters to even rescue these people? Boats would be needed. How will governments be able to replace all the destroyed infrastructure? More importantly, what will we do about the sudden lack of fresh water? With our fresh water mixed with salt water, humans now have a serious lack of drinking water. Suddenly, the land in the interior has become the hottest property. People living in the US Midwest are super happy they were never ever part of the wealthy coastal elite. Denver, Minneapolis, and Las Vegas are looking more attractive than ever before. Now, nations in the southern part of the globe are hit even harder. All of Bangladesh, with a population of 160 million people, is underwater. Geopolitical tensions rise as countries are looking for aid, but since so many places are hit, help is hard to come by. Now that all of the ice is gone, there's still another thing that has to melt: the permafrost. This is the soil that's been frozen at the poles for more than 40,000 years. As it thaws, it releases the carbon dioxide and methane that are trapped underneath it, causing the Earth to warm more and melt even more of the permafrost. As the permafrost thaws, it's as if someone popped a frozen dinner into the microwave. Tiny organisms start to munch on the freshly thawed ancient organic matter. As they do this, they fart out carbon dioxide and methane, which causes global temperatures to rise even more. Great, now we're breathing in microorganism farts and it's getting hotter. Worst scenario ever. Oh, but it can get even worse. In the midst of all this, it's possible that DNA viruses in the permafrost will thaw and kick off a global pandemic. Creating a vaccine in the midst of this catastrophe would be a challenge like never before. Plus, it's hot. Earth is 5 to 10 degrees Celsius warmer. The heat is what's driven the entire ice sheet to melt, but now these changes are making it even hotter. With the average temperature on Earth now almost 27 degrees Celsius, a mass migration of people begins. The most popular spots? Well, Canada, Alaska, and the newly unveiled Arctic and Antarctic regions. These are the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest like New Zealand. Maybe that's going to happen all over again. Palm trees on the Antarctic coast and alligators swimming in the warm South Ocean. Thank goodness Antarctica is not actually melting in a matter of minutes. With coastal cities turning into watery graves, 3 billion people dead, our groundwater contaminated, more warming on the way, and maybe a global pandemic, I can't think of a worse situation. Unless, of course, land and water suddenly switched places.
What if we found a way to drain all the Earth's oceans through some mysterious portal at the bottom of the Mariana Trench?